guys, my name is Jain, and today I'll be going over tree traversals for you guys. So let me go ahead and share. So we're going over tree traversals as I just mentioned. And the first thing I just want to make sure you guys know is the trees that I'm going to be referring to are going to be using a integer value. So we're going to be storing an int inside of our struct. And obviously our struct also has a pointer to the right and left. That's just some notes that I want to make sure you guys know before I go into it. And the other thing I want to make sure you guys know is I'm talking about binary trees specifically. So for example, you might see something like this as a binary tree, where this would be the left pointer and this would be the right. And the other thing I want to mention is that terminating nodes are the ones that have a left and right, each left and right pointer pointing to null pointer. So you might see that referred to as well. Okay, so I think that's everything I needed to introduce in the beginning, at least. So let me just give you guys a quick outline of what I'm going to be going over. So I'm going to be going over pre-order traversals, post-order traversals, and in-order traversals. So I'm actually going to write it in this order. And I'll go over level order traversals, and then if time permits, I'll go over a sample question. So let's go ahead and just talk about a specific example. So the tree I want to use is actually going to be a binary search tree, but it really doesn't matter for traversals which tree you pick. It's just for this example, I decided to choose a tree that happens to be a binary search tree. Now, the first thing I want to introduce is the different ways we could traverse this. So the easiest way to traverse a tree is to use recursion. And by what I mean is we treat each tree as 3 nodes, because that's all it really knows. It knows what the right node is, knows the left node, and it knows its own value. So if that's all I can see, then we need to make this into like a bunch of subproblems. So for example, we want to make this into one problem, we want to make this into one problem, and we want to make this into one problem. So that's how recursion is going to be simplifying our case for us here. So now that I've introduced the idea of using recursion, let's talk about like how we could potentially use recursion to get all of the tree nodes printed out, which is kind of the point of a tree traversal. And I guess one more thing I just want to comment on is the reason we do tree traversals is to see the entire tree. So we just need to make sure that we hit every single node. And the main ways we can do that is we can print out the current node. So I'm just going to keep it simple and just kind of do this, where the current node is just pointing at a node. And then we want to do the same thing for the left subtree and the same thing for the right subtree. So let's say we did do this exact same, I guess, like pseudocode I wrote here. And what would the pseudocode give us? So I guess to slow down a second, what this pseudocode is really saying is we want you to print out this node, and then we want you to do the same thing for the left subtree and then the right subtree. So it would pretty much go to 3, it would print that out, go to 1, print 1 out, and then it would print out -1 because it goes to the left subtree again, and then it'd print out 2, which is the right subtree, and then return here, return back, and then go to the right subtree, print out this. This is a null pointer, so we skip it. And then we go to 5 and then print that out because it's the right subtree. So well, based on this code here, we're going to go ahead and see that we're going to return -1. So oops, sorry. We're going to return 3, 1, -1, 2, 4, 5. Okay, now the interesting thing is if I change the order of these 3 lines that like I wrote right here, we're going to get a completely different order. So as you can probably guess, we call this ordering pre-order. And the reason we call it pre-order is because we print it out before we do any other analysis. So an in-order means that we would do the left subtree. So if we do the left subtree, then we would print out the current node, and then we'd go to the right subtree. Now, what does this really mean for us? Well, in this case, we go to the current node. So we're here. We see that we're supposed to go to the left subtree first. So we go here. Wait, there's another left subtree. So we go here. Okay, we can print this out. So we print out -1. Okay, now we print out the current node, which is 1. And then 1 is going to call the right subtree, which is 2. So we're going to go from here, return. This is going to go to the right subtree, and then return. This returns back to the 3. So we're going to print out 3 now. And then we're going to go to the 4. So the 4, well, the 4 doesn't have a left subtree, so it returns from that. And then it goes to the 4, prints out that. And then for the 5, it's the right subtree, so we print out the 5. So this is how in order would look. And the last way that we could do this is if we did left subtree, right subtree, and then printed out the current node. And the way we could do this is if we did it in this ordering. What we'd end up seeing is, well, okay, so we go to the left subtree. We see that we can print out -1 as the first value we can print out. Then we can see that the next one we'd want to print out is actually the 2 because there's no print current node. So we print out the 2, and then we would go to the 1. So we'd go the left subtree, the right subtree, the current subtree. So that gives us 1. And then on the other hand, we go all the way to here. We'd see that there's no left subtree. So we print out the right subtree first. So we get 5. From the 5, we're going to go ahead and get 4 as the next one, and then 3. So it can be a little bit tricky, and it's really easy to make a mistake on this. Fortunately, there's a little trick that you can do. So let me just go ahead and copy this guy and put it below, and I'll show you guys the trick. So what the trick for these type of trees and figuring out which traversal order will give you what is you can actually just draw an outline. And I'm going to try and make it as tight as possible just to show you guys how it would look. Now, the thing that you might notice is, well, if we put a left dot to the left of every single number, and based on the starting point being here, and we're going in this loop around this way, you might notice that that order would actually be the same as the one that we got up there. So we'd get 3, then we'd get 1, then we'd get -1, then we'd get 2, then we'd get 4, and then we'd get 5. So that's the exact same ordering as this one. So if we drew a dot to the left of it on our outline, that would tell us the order for pre-order. And this is really useful for checking your work and making sure that you're actually doing it correctly. Now, we can do something similar where we do a dot under the number. And the way I like to show this is, well, let's just say we did this for this one. So we go all the way to the left, finally get a dot under -1. We get a dot under 1, and then a dot under 2, then a dot under 3. Wait, this is the same order again. 4, and then 5. And that's the exact same order that we would also see here. So you can probably take a guess what the post order would be. And if you guess that it would be a right dot, so a dot on the right side of the number, you're exactly correct. So if we go all the way down, we'd see that -1 would be the first one that has a right dot. Then we go here, see that 2 is the next one, then C1 is the next one, then C5 is the next one, then C4 is the next one, and then C3 as the last one. And you can see that that's reflected here too. Now, those are the 3 main ways that you'll see of ordering your tree traversals. And unfortunately, I don't think I'll have time to go over the sample question, but I do want to introduce you guys to the idea of level order as well. And all a level order says is, I want you to print out by level. So for example, in this case, it would just be 3, 1, 4, -1, 2, 5. And this is actually really easy to see. It's take all the numbers from left to right on the first level, on the second level, third level, and then so on if there are some more levels. But it's actually pretty tricky to implement. And I think the easiest way to implement it would be using the height of the subtree. So if we know that the height of 3 is 1, 2, so there's two numbers underneath that, that tells us the height of this guy would actually be 3. The height of this number, well, there's 1 underneath it, so it'd be 2. Likewise here, there's nothing under it, so it'd just be 1. And all of a sudden, you have numbers. So you can calculate the height of each value using this method. And what it pretty much is saying is like the height is equal to the largest pathway down. So it's just equal to the max, I guess technically height of left subtree and right subtree. I'm just going to abbreviate that. I'm fortunately going a little bit over, so I apologize, but more or less that's the idea. And then based on that, we can print out, we can put it into a vector int or vector array or array of vector ints and have 0 correspond to the first height. So like the max height minus that. So once you have the height, it's actually pretty easy to arrange. So yeah. So that's generally the idea behind the different ways of tree traversals. For leak code problems, to like kind of practice these ideas, you can look at 106, 105, 98, 102. Those would be the ones I recommend. And the last thing I want to just mention about tree traversals is these pre-order, in-order, and post-order actually have kind of a distinguishing factor that I want you guys to notice. So you might notice that -1, 1, and 2 is on the left subtree. And we can actually see that really easily in our in-order. And we can also see the right subtree pretty easily on that. So if you ever need to calculate or figure out how a tree looks like, if you have the in-order and either the pre-order or post-order, you can actually figure out how it's going to look. Because the pre-order will tell you what the root node is because it's the first element, and the post-order will also do the same thing because it's always the last element. And then you can break it into a sub-problem because you just take these two guys. And likewise, you could take the array here, and that would tell you exactly, oh, so I only want to look at these values, I want to look at these values, and make it into a sub-problem. So you can break up the problem like this. And Yeah, I hope I helped. That's the general idea and general introduction to tree traversals. And if you guys have any questions, obviously feel free to ask anyone in UPE or come to our tutoring office hours. Thank you, and I hope this helped.